Hello and welcome to today's lesson on mains electricity. Our learning objectives are to describe the domestic electricity supply in the UK, that is what we have coming out of the plugs, explain the difference between direct and alternating current, which is quite important when we're talking about transformers, describe the function of the wires in a plug, the potential difference between them, and why we have an earth wire, and finally explain why live wires can be dangerous even when the appliance is not turned on. The domestic electricity supply in the UK, often called the mains or mains electricity, is supplied at a potential difference of 230 volts and with an alternating voltage of 50 Hz, which means it switches from being positive to negative 50 times a second. It's transmitted to our homes via the national grid, which we learned about last lesson. If we connected the mains to a device called an oscilloscope, it would allow us to draw a picture of how the electric current varies in an AC supply. And here we have both DC and AC. On the left hand side we have a direct current source such as a battery producing a constant current, and on the right hand side we have an alternating current, something like the mains electricity. The important point to note is that part of the time it is positive and the other part it is negative, and it switches backwards and forwards. In the case of mains, it switches 50 times in a second. In the UK we have the 3-pin plug. 2 or 3 of the pins will be connected to internal wires, and the wires will be made of copper because copper is a good electrical conductor. Around the wires are a layer of plastic. Plastic is used because it is a good insulator. I'd now like you to answer these 2 questions in your book. First of all, state 2 reasons why brass is used to make pins of the plug, and secondly, state 2 reasons why copper is used for the electrical wires. Now, you should be able to get the first mark for each of these 2 questions, but we'll have to think quite hard to get the second mark. Pause the video now while you try and come up with your answers. And now for the answers. Firstly, brass is a good electrical conductor. Hopefully most of you got that one. Slightly trickier for the second one, brass doesn't easily rust or corrode, which is why you see brass numbers often outside people's houses. Copper is used as a good electrical conductor, and it's also ductile, which means it can be stretched easily into wires. Wires are colour-coded to make it easy to identify which is which. The live wire is the brown wire, which will be at 230 volts. The blue wire is the neutral wire, which will normally be at 0 volts. And there's also a third wire for most appliances, which is going to be green and yellow striped, and that is the earth wire. Many appliances have a metal case on the outside. Now, if the live wire were to come loose and make contact with that metal outer casing, it would make the whole appliance live. This is the reason we have the earth wire connected to the metal casing. If the live wire comes loose, it has a direct route to earth with very little resistance, which will produce a high current which should blow the fuse and make the appliance safe again. Some appliances don't have an earth wire and will only have a live and neutral wire. This is because they either have plastic casings or they are doubly insulated, so the wires can never come loose and come into contact with a metal surface on the outside. I'd now like you to try and answer these 3 questions in your book. Take your time and pause the video while you're working before you come back to it. And here are the answers. A would be the live and neutral wire. B, the item would need to be doubly insulated, and C, it stops the person making contact with the live wire. Fuses are used in all sorts of electrical appliances. If the current flowing through the device becomes too great, the current will melt the fuse, breaking the circuit. Here we have a question about someone who is considering replacing the fuse in their home with an ordinary piece of wire. Firstly, we want to explain whether the appliance would work again or not, and secondly, suggest whether it is safe or what the dangers are. Pause the video now while you answer the question in your book. To answer the first part of the question, yes, it would complete the circuit and make the device work again, but no, it would not be safe because the wire wouldn't necessarily melt easily when the current gets too high, so it could become very dangerous. Here we have a simplified diagram of how to wire a plug. On the right hand side we have the live wire, which will also be connected to the fuse. In the centre you may have an earth wire, and on the left hand side you will have the neutral wire. You'll also see that there's a cable grip across the outer insulation, and it's important you get it across the outer insulation. The switch for a device and its fuse will always be on the live wire. Why do you think that is? Take a minute now to think about it. Pause the video if you need to, and then we'll go on. The switch is always connected to the live wire, so when the switch is turned off, the device is not left live. I'd now like you to write a short sentence or two to explain why the live wire could still be dangerous even when the device is turned off. Pause the video while you write it out, and then we'll come back and look at it. The live wire inside the cable would still be at a high voltage, even though the rest of the device was switched off. A kettle is plugged in and switched on. The live wire becomes loose inside and moves to touch the neutral wire. The live and neutral wire are now in direct electrical contact. Explain why the kettle stops working when this happens. Pause the video while you write down your explanation. This is what's known as a short circuit. It produces a low resistance route for the current to flow from live to neutral, and so the current can avoid travelling through the much higher resistance filament in the kettle. As a result, the filament won't heat up. I'd now like you to explain how fuses can reduce the risk of overheating or fires. Pause the video while you answer the question. The fuse will be in series with the live wire. When the current becomes too great, the fuse will melt. This will break the circuit and stop current flowing through the rest of the kettle. In this problem, the live wire has come loose and touched the metal outside casing of a kettle. Explain how the earth wire prevents someone from getting electric shock if they touch the kettle. Pause the video while you answer the question. Current can flow to earth through the person or through the earth wire. The route through the earth wire is much lower resistance, and so this is the route the current takes. Here we have a picture of a very poorly wired plug. What I'd like you to do is pause the video and try and identify as many issues with the way this plug is wired as you can. When you're happy, restart the video and we'll go through some of the issues. One issue is that the wire on the left hand side has far too much exposed copper wire sticking through. This could come loose and cause a short circuit. Another issue is that the live and neutral wire have been reversed. In this case, the fuse is now connected to the neutral wire, and so if the fuse was to blow, the device would still stay live. The cable grip should be placed over the black outer covering. You may also be able to see that the brown insulation has been damaged when the lid was refitted. It's worth noting that on this one there is no earth wire, and that may well be fine for this device. Not all devices have 3 wires. I'd now like you to sketch this diagram into your books using half a page and identify each of the 5 components. Pause the video while you work through it. And the 5 components would be cable grip, neutral pin, earth pin, live pin and fuse. And here are some extension questions. These aren't mandatory, but if you'd like to take part, pause the video now while you work through the questions. Please make sure you label them as extension work in your books. And as you can see from the maths presented here, if we had 4 4-amp appliances, it would draw more current than a 13-amp fuse would be capable of dealing with. And 2 more extension questions for those who'd like to try them. Once again, these aren't mandatory, but if you'd like to, pause the video now while you work through these final 2 questions. And here we have the answers. Please go through and mark your work, and if you've missed any of the content, feel free to add it in. That brings us to the end of today's lesson. I hope you found it useful, and thank you very much.